Hello, good morning, sir.
Good morning.
How are you, sir?
Fine, fine.
It's not an issue, sir. So we will just start after 1 or 2 minutes.
Yeah, sure.
The more participants will join in the meantime.
Yeah, yeah. Till then, let me. Okay, from Safari, it will not support sharing. Something is happening. Switch to desktop app, Chrome. I think I have to open in Chrome. It's not supporting sharing. One second.
Take your time, sir. No
Yes,
issue.
yes. Yeah.
Yes. Good morning to all participants. So I welcome you all here. This past day of this FTP on which is organized by AMWC and Airport. So before start the session, let me introduce Dr. Bear. So today's session that will be delivered by Dr. Ranjan Bera sir. Sir, he is a data scientist at ExxonMobil and previously part of the core AI research team at Reliance Jio. He holds a PhD in science from IIT Guwahati and specialized in natural language processing, audio intelligence, and multimodal learning. His work spans impactful AI applications across telecoms and energy sectors, focusing on scalable foundation model-driven systems. Dr. Bera brings hands-on expertise in LLM, efficient audio transformers, and speech processing, and research published at top venue like ACL, ACA plus Interspeech, ECML, PKDD, and IJCN. He is also known for award-winning projects like real-time cricket analysis using NLP. So we are excited to have him here today to shed light on rapid prototyping with trained NLP model. Dr. Bera sir is with us. So welcome to Dr. Swaroop Ranjan Bera sir.
Yeah. Hello, everyone. I think you can hear me. So there is some issue with. So basically, I'm using Mac. So Mac, I'm unable to share my screen. Uh, what to do? Just give me a few minutes.
Yes, yes, sir. It's okay, sir. Take your time, no issue.
Just give me 2 minutes. I'm downloading the app.
It's okay, sir. No
Yeah.
issue.
So somehow it's asking me to register. I don't know why.
Yes, sir. Maybe you can register from the mobile itself.
Okay. Or what I can do is, can I share you the PDF so that you can share and I can
Yes, sir. Yes, sir. Yes, sir.
that will work, right?
Okay, sir. Okay.
So should I share it in Vikas WhatsApp or email? Or do you have any email where I can send the PDF?
Hello, Vikas sir. Are you here?
So you can share with me. You can share directly in our mail.
Just can you paste
Yeah,
the like email address in the chat so
yeah,
that
yeah. Yeah.
I'll upload.
Let me
Yeah.
give me some.
Sorry for the issues. Yeah. Yeah. So I've sent the slide. Please, someone open and just share the screen. Okay.
I think it should be visible, sir.
Yeah, let me see. Yeah. Okay. Yeah. So can you make it full screen, or others are you able? Just. Yeah. Sorry for the delay. So should I start?
Yes, sir, you may start.
Yes, sir. Yes, sir.
Yeah. Yeah. So you have to help me in between. Basically, there are few, let's say, Google Colab notebooks. You have to just open it and just click. You don't have to run it. Just show me so that I can explain. I wanted to run few things and show, but it's okay. We are running out of time, so we should start. Let me open this thing here. One second. Let me see my slides as well. It's too many today. Yeah. So yeah, we can start. So hello everyone. Thank you for joining. Sorry for the delay. So as I'm Swaroop, I basically work as a data scientist in ExxonMobil. Before this, I was a research scientist in Reliance AI. Right. Today's talk is about something that I believe is fundamentally changing how we build an NLP system over the years. Right. And so that's why this topic. So I wanted to give you all of you a hands-on session plus how you can rapidly, because all these past few days you have gone through all the theories, right? Like what is like from ML to DL to all these NLP, computer vision, reinforcement learning, all these kind of things. But I wanted to have a small session where you can see how you can quickly build those models and show it to the stakeholders, let's say, or show it to the students or people who matter, right? So that's why this topic, rapid prototyping with pre-trained models. So just someone confirm, is my voice clear or should I have to speak louder?
Yes, sir, your voice is clear.
Okay, thank you. Yeah, so whether you are a teacher, researcher, or engineer, or you're just starting NLP, you will see how the right tools can take you from an idea to a working model in minutes without needing to train anything from scratch or without coding too much. So that's how I wanted to cover today. So we'll cover the core model ecosystem, how today's NLP works. Then next, we'll cover what are the practical tools like Hugging Face or Gradio, or without coding, how you can basically infer a model or output from a model or train a model, and how prompting works as well with brief slide, right? Okay, sir, next slide. Yeah. Yeah. So let's start by acknowledging how much this NLP landscape has shifted in last 5 years, let's say. Traditionally, building this NLP system meant collecting task-specific data set, train a model from scratch. If you have trained some previous models, traditional models, some as SVM classifier, let's say, or linear regression or something, or LSTM or BERT per se. But now it has completely changed to just loading a pre-trained model and just fine-tuning with few thousands data. All right. So that's why this slide, you don't start with a blank slide anymore like we used to do. You start with a model that has already read the internet. I think all of you must have used a ChatGPT and such models. So basically, these are already trained on whatever data you see on internet, petabytes of data. This is called pre-training, right? Then you can just prompt it and it does your task. So we'll see how it happens actually. So basically the models like BERT, GPT, or T5, which are available off the shelf, it has completely changed the way we do NLP. Right? You don't have to start from zero, and now basically we have shifted from training the models to prompting, as you do in ChatGPT, or feature engineering to basically model orchestration. We'll see how we do that. So what it means actually, basically it speed ups your research iteration. You can quickly build in hours your MVPs, product MVPs, and you can quickly do the academic experiments in hours that used to take days, let's say, right? So that is the whole idea today, how to prototype these models and showcase to the world using very powerful tools for free, let's say, and with minimum effort. Sir, next slide. Yeah, so I've just put a visualization for you. The above is the way we used to train the NLP models. And let's say you have your data, you have to make it structured, let's say, often like your, let's say you're training a sentence sentiment classifier. You have to, there has to be, let's say, two column you can think of. One is the sentence or tweets or messages. The next column is the label, whether it's a positive sentiment or negative sentiment. So like that you have to do task specific training you have to do. The downstream is the current NLP framework. So think of a chat GPT basically, or any model. Let's say now if you want to do sentence classification, you don't have to have let's say 10 50,000 1 lakh data points or messages with levels, because we all know getting those levels is very difficult. Now what you have to do is at the lower row you can see basically already you have models like BERT, GPT, smaller models, not Chat GPT. I'm saying there are various models. They're already trained on, let's say, pre-trained on. This is called pre-training on unsupervised data. So basically, how it works is they'll scrape data from the internet, and there will be many tasks. Basically, one task is next word prediction. So basically, if the sentence is "I am eating ice cream," so what happens is I, the next word is am. This is one training data. Then I am, the next word is eating. Eating is your label. This is called next word prediction. So basically like this, it has trained. They have trained these models. And now after you do this pre-training, your model knows how the English, let's say if it is trained on English data, how the English semantic works, what is the meaning, and how the syntax works, how the sentence should be structured. And it knows many world knowledge as well, right? Because it's trained on most of the data. Then if you want, in the second part, you can see your base LLM is ready. Then if you want to fine tune it to sentiment classification task, now you just need a, let's say 1000 examples level data of, let's say, tweet and the sentiment. So this become very easy. I am sure you must have gone through this pipeline. I just wanted to give you an overview. Now you have a fine-tuned model which mostly works better than your traditional models, right? Okay, sir, next. Sir, next slide. Am I audible?
Yeah, you are audible. We are having some delay at our end.
Okay, okay, okay. There was a previous slide. Yeah, so basically, the way I told you how this traditional NLP works, I've compiled a simple code for you. So I'll share this slide. You can just click it and run it at your Colab. I'll discuss about Colab is one such tool where Google Colab, let's say Collaboratory, where you can freely get GPU access and run your codes. So just click it and show them. Like, we don't have much time. I wanted to have a proper walkthrough, but we don't have much time. I'll just tell them what I have compiled here. So basically this say you guys all have read research papers, right? You don't have to run, just open it. Yeah. So this is one such task. So others, are you? There is a message that they're getting less audio output. So are others? Am I clear enough, or should I speak louder?
No, maybe from that side it may be problem. It is clear.
Okay. Okay. Sure. Thank you. So basically, this is a traditionally how we used to do text classification. So the task is you have already research papers. So given so let's say it's a research paper about diseases. Given an abstract of the paper, you have to predict or classify it to a particular disease, right? Okay, so sir, in the read data, you can just expand. I'll just tell them. I wanted to run it, but anyway, it is already I've run it. Yeah. So basically, so Colab is. I'll talk about Colab for now. Let's say you have to get. You can get the data using wget. Let's go down. Let's say unzip the contents, all the JSON files, training data. Go down. Yeah. Then you can just some processing, then some imports. You can open the load train file, sir. Yeah, so here basically we load the training script. Load the training script, and the data looks like this. Basically, you have an abstract and you have a category like disease. Like this is the diseases. Second column you can see. As I've told you, in the traditional flow, you needed structured kind of data, right? Then, sir, you can open the test files. These are same thing but on the test set. Then let's go to step 2, because these data are not processed. You have to process the data. Yeah, there are a few cleaning steps where you can do it. You can lowercase it, then remove some digits because these are not necessary to identify the disease. Then if there are some punctuation or something, you can remove those. Sir, you can go down. I just wanted to have a clear overview, give them an overview so that they can go and run. Yeah. So basically now, because see, we don't know how many classes are there, you have to check the class distribution. So this is the class distribution, and you can go down, sir. There will be some plots as well. So yeah, so this is the x-axis. You can see the diseases, and y-axis you can see the counts. So you can see that class are not properly distributed, right? Okay, sir. Next, go down. Yeah. So basically, these are some insights. The distribution of the classes is not uniform, highly skewed. Top 7 classes has 58% of the data. And you can check the word distribution as well. We can go down, sir. Yeah. So it's basically insight. We can see just up a bit. Down, to the insights. Yeah, so basically from the word distribution you can get 75% of the abstract has less than 240 words. This is to make sense, because some abstract you have to somehow clip it somewhere, right? Because let's say longest abstract is 939 words, let's say, but most of them, they see 99% of the abstract is 400 words. So you have to clip it. Okay, sir, let's go down. Yeah, so you can see all these things, then you can have some insights, and based on that you can, maybe if the class distribution is not good, you can mend that. So basically you can use various technique to make it evenly distributed, right? Okay, I think we should skip it. So just I wanted to say that this code contains, sir, if you can go down rapidly, I'll just tell it, you just show them. So basically first it will train a ML algorithm, SVM, let's say. Then it will, you don't have to expand, just go down. Then it will see how we can measure accuracy and F1 score. Then how you can train a LSTM. LSTM used to be a very popular model in NLP. Then came the transformer. So it has the code for training BERT as well. But all this uses mostly the first one, SVM is proper traditional flow, LSTM as well. But I think we are loading the model and running it. But most of these involves how we used to do NLP traditionally. Next, sir, we can go to the slide. So I want you guys to run it, okay, and pass this to your students as well, so that they have a hands-on actually what is happening. Yeah, sorry to trouble you. I think I'm putting you in a very tight spot. Yeah. So yeah, so we have 30 minutes left. I will make it a bit faster. So this is what. Let's take this moment to see how the timelines of last 2 decades in NLP evolution looks like. We started with simple bag of words model. So basically, I think you have read, so I am not going to explain it. We have to move faster. Then we moved to What2Vec in 2013, let's say. Then everything changed at 2017 when the attention is all you need paper can. Basically, it introduced transformer, right? Or the attention mechanism, which changed the landscape of NLP. So you can see here this uncolored, let's say, it was non-transformer kind of models. So colored one, you can see 3 categories. 3 major categories of architecture of models exist now. So first one is this, let's say purple one is encoder only model like BERT, Robota or DistilBERT, which are great at understanding meaning. We'll discuss in a few slides for them. Meaning of, let's say, sentences or understanding of the task, like classification and your sentence similarity. Second categories is, let's say, decoder only model like GPT, GPT-2, 3, ChatGPT, let's say. So these are optimized for generating text. You all have used ChatGPT. That's why it makes it ideal for chart, storytelling, or open-ended task, right? And third one is this one, green one is encoder decoder model. So basically like T5, Flanty, something, and switch also there was a model. These are very good for transformation kind of task like summarization. Given a paragraph, summarize. Translation, given an English sentence, summary to Hindi, translate to Hindi, and some text to text mapping as well. So this is how this landscape look like. So we can go to next slide. Yeah, so basically I've just an overview kind of, or recap kind of. So this is like the first major family, like encoder only models or BERT style models. You can see here these models in the picture right side. I put a diagram. So they'll take a full sentence or even a pair of sentence and process them bi-directional attention, self attention, right? Then after that you can see this, you can get a very rich embedding for each token. And because because of the structure, you can see basically encoder are not one layer, these are stacked encoders, right? These are very good in, as we have talked about, classification, entity recognition, semantic similarity, where we use embeddings, meaningful embeddings. We'll skip faster. Next slide. Then we have these are decoder only models. So I think you must have gone through how this decoder and encoder architecture looks like. So let's, here you can see, if you want to see, basically you have a self attention, then feed forward, right? But in decoder you have extra one, this encoder decoder model, you have this cross attention as well. Yeah, so these are like the decoder only models, bit different from uh, uh, encoder in the sense that instead of taking the entire sentence to understand it or generate embedding, they take the prompt. Let's say here you can say I love, then it's kind of a prompt. Then they're like engineered to predict the next word. Let's say ice cream or llamas. Based on the probability, higher probability term, they'll predict the next word. Basically, when you ask ChatGPT to write an, let's say, short biography for me, right? So basically it's just trying to, based on the previous information or the context you give, it's trying to predict the next word only, next word, next word, next word. That's how it become a paragraph. So it's just a next word prediction in a long context window, you can say. So these are best for, yeah, text generation task. Next is encoder decoder model. I think let's skip it because it has both the encoder and decoder part, and it's best for summarization and translation. One thing is that most of, I just wanted to tell you that most of the LLMs, or what are the names you heard, like GPT, Cloud, Llama, Mistral, Gemini, all of these models are now using decoder only model, because this field is moving so fast, and this architecture or computation is very scalable and adaptable with this prompt tuning and all, that with decoder only model you can achieve all these tasks, like whatever this classification kind of task, NER task, or uh, this summarization or mapping task, everything with the scalable models and compute and data, you can achieve everything on decoder. So most of the model you see today, LLMs, are decoder only model. Sir, we can go to next. Yeah, so then we'll just see, as the talk was for this one, the tools. I wanted to introduce you to some tools, like some powerful tools, which that can help you run a model with one line of code, let's say, build quick inference and share demos with others. Let's say you build a classifier, or let's say was a sentiment analyzer. You can just quickly build the app and share it with others. Okay, this is what I've built. Or if your students are doing these projects, instead of just showing the code and the accuracy and all those things, they can quickly build a UI and share with the panel members, right? Kind of demos, let's say. And you'll, after this, you'll be able to train your models without deep machine learning coding knowledge, let's say. Or you can completely skip the coding and use 0ML kind of thing. So first tool is the most basic but most needed, and this is the cloud notebooks. So basically, to run all these modern day tools, you need compute GPUs, and mm, and the laptops we have at home, let's say, these are not high end. These don't have high end GPUs and all. So how can you run your codes? Because these, all these models that I'm going to talk about will use GPU and space as well. Excuse me. Yeah. So few people have started. I hope all of you have used Jupyter notebooks. So basically, you can see it's a visual UI kind of Python interpreter, you can see, where you can, in Cell you can run code and see the output there only, so that you don't have to compile it again and see it there only. You can do this is very good for rapid prototyping, Jupyter notebook. So few vendors like Google or Kaggle or Hugging Face, they've started hosting their cloud notebooks, where they'll provide you free GPUs and space, GPUs, TPUs, CPUs, and space, where you can run the notebooks in their server. So basically, you can, from your mobile, you can run it, from your iPad, you can run it, from your simple notebooks, you can run it, right? Note laptop, you can, MacBook, you can run it, and you'll have this GPU access. So these two basically are mostly. Colab is very popular, and Kaggle, because of this data sets and Kaggle competition. One difference is your Colab will not store your model data after some time, let's say, but Kaggle, you can run it and store your model as well, right? Again, these are free access, then subscription based. You'll get, if you pay, you can get subscription and get more compute resources and all, right? So these two I wanted to just show you, so that we'll go and execute few codes now. So next slide. Yeah. So so I'll show. Yeah. Yeah. Thank you. I wanted to say that. Yeah. We can quickly see that. Uh, Same thing. All these link. Yeah. So basically, if you have not, I hope most of have run it, but if you have not run it, basically it's like a Jupyter notebook where on the left there is this file thing where you can upload your files in C. Sir, can you click on the left panel? This file link is there. File icon is there. So here you can upload your file and all to process. Yeah, here upload button is there. There you can do. On the right, top right, you have. I just wanted to show them how they can select like GPUs and all. Yeah, change runtime. Can you click change runtime? Yeah. So basically here you can select, because if your task is very simple, if it can be done by CPU, you can select CPU. Then you have T4 GPU and V2 8 TPUs. So TPU is basically Google's tensor processing unit. It does few tensor kind of tasks very easy. Right. So these three are freely available. Then if you can pay, you can get this A100, because to train or fine tune bigger models, you need this other high-end GPUs, right? Okay, so we can cancel it, I think. Yeah, so we'll come to this rapid prototyping after few slides. So let it open up, like let it be like that. We'll go to the slide, then we'll come back in. Yeah. Yeah. So next is I wanted to introduce the Hugging Face ecosystem. So what it is, basically it's a, as I've written, Python library. Basically it hosts at the starting of NLP. Basically Hugging Face started this revolution of hosting all these models. Basically you can go and search, like it has all the models, like I think 100k plus models. It has too much of data sets, and it is very I'll talk about pipelines, but the main thing is whatever model you want to search with 3-4 lines of code, you can just infer it from Hugging Face. They have hosted all these models and data sets, right? So right now, whoever the companies, industry, or the academics, research as well, whoever uh, build something, they'll put it on Hugging Face, so that if they want to make it open source, right? So you can get all kind of NLP, computer vision, audio, these kind of models in Hugging Face. So it'll be your go-to place if you want to do some prototyping or something. And let's talk about pipeline now. So at the core of this Hugging Face transformer library is the pipeline. So basically what it does is, so when you, let's say, train a model or something, you have to load the tokenizer, load the model. You have to, it's not easy. You have to do many things to, let's say, infer as well. So it's not easy. So what these guys have done is they put everything in a pipeline. Let's say you just have to call in one line, you can get everything of the model. They have sort everything for you. Just in one line, you can run any model. So this is perfect for academic research or classroom experiments or industry POC. Hugging Face for any NLP or AI guy, it is the go-to place. Yeah, from data set to model building to evaluation, and it has space as well. Basically, you can, after you build your model, you can deploy it there. So basically, you can have a UI as well. So everything end to end, you can do it Hugging Face. And the way I've talked about Colab and Kaggle, so basically you can do that in Hugging Face as well. So to be a proper NLP expert, let's say, Hugging Face is a must. Okay, sir, we can go to next slide. Is there a delay? Yeah. So I think we have already opened this. So let's go to that Colab page. I've already run it yesterday night, let's say. So I'll just show it, and we'll share the slide with the participants, so that no, it is already open, the first one itself. Yeah. So when I tell how we can use Hugging Face transformer for rapid NLP prototyping, this is how we do it. So all these notebooks that I'm going to show you today are, let's say I've opened, the link is open to all. So basically I'll share the slides. Sir will share the slides with you. There you can get all these links. I want you to go through, just everything is there. You just have to open it on you must have a Google account. It will open it. You just have to run it, right? Just please run it and see how this works. So how it works is basically, this is how you pip install transformers, install the Hugging Face. Sir, you don't have to run. It will just vanish. We don't have time. I have already run it, so it is there, right? Then you can, I've told you, they have in pipeline, they have kept everything. Okay. So you don't just import pipeline, then you can get all these models. So I've shown you how this classification works in traditional NLP. It must have in some 200, 300 lines of code, right? Everything. So like that sentiment analysis also work. So with Hugging Face, see, you need only one line. So basically you have to do sentiment equal to pipeline. Then you just have to call sentiment analysis pipeline, right? So once you call it, you can see here, it is downloading the model weights, then tokenizer, then vocab, everything, right? So this pipeline, they have sorted out everything. You just have to, in one line, now you got a sentiment classifier. How you can use it is print sentiment, then your sentence. Let's say this NLP workshop is excellent. So you can see here at the bit down, you can see the level is positive. So basically it means it's a positive sentiment with the probability. Score is 0.99, right? Or 99.98%. Then I've just put a not. Let's say this, NLP workshop is not excellent. Now the level become negative and score is 99.97. Right. Same as zero shot classification. Zero shot means without giving any example. We'll see in the prompting. I'll discuss that. Hopefully we'll be able to cover. Then just one line, zero shot equal to pipeline. Then sorry, second. Yeah. So basically zero shot equal to pipeline, zero shot classification. With this one line, your classifier is ready. You can see it has downloaded the model JSON, then weights, then tokenizer, then vocab, merges. Just if you want to learn, just in ChatGPT, just paste this. I'm getting this output. Can you explain me what is happening? So it will explain you all the things. What is model tensor? What is tokenizer? So basically nowadays learning become very easy. You have ChatGPT, whatever you don't know, ask that. Obviously it may hallucinate, but you have an assistant ready to assist you, let's say. So here you can see how you can classify is basically, this is a sentence. This is a lecture about deep learning, what we are, let's say, discussing. So this is your labels: education, sport, and technology. So what we're doing is we are asking it to, now in the sentiment analysis, you have only one input, the sentence only. Here we are having two inputs. One is the input sentence, which we want to classify. Second is the classes. So here you can see for three levels, it has identified the probability, and highest probability is the 76%, which is technology, right? This is how this, with one line, basically you can do all this. So we can go down. Same, this name entity recognition, it works like basically name entity recognition. If you know, it's just a task where in a sentence it will identify the real world objects such as personal location, as such. So basically here in the sentence, my name is Alice and I live in New York. So if you see the output at the end, so you can see this Alice is the person, PER is the person, and New York is the location, LOC. So it is able to identify. So we can go down to the summarization. Similarly, summarizer, with one line, your summarizer model is ready. Here we have given another argument, which is which model we want to use. Previously, we are just using the pipeline. I just shown you so that in other pipelines as well, you just have to go to Hugging Face, find a summarization model and just copy this one, their name. Like Facebook is from the organization, the model is published, and there's the name, BART model, BART large CNN, right? Then summarization is basically given as paragraph you have to summarize. So it is able to do it. Due to time constraint, we have to skip. Let's go to text generation. Similarly, text generation, it works basically given a text, deep learning and transforming. Max length, another parameter. We want to generate max 30 next tokens, right? And number of written sequences means how many variations of sentence you want. We want only one sentence. Here you can see it has generated. Deep learning is transforming the way here we stopped at transforming. Basically, it's just next word prediction. After transforming, what is the probability of occurring out of all this vocabulary? The is having the highest probability. Then deep learning is transforming the. So next, out of all vocabulary, way is the highest probability of occurring. So like that, based on the training data, right? Because each model, GPT will give different output. Your Gemini will give different output. So this is how, with one line of code, basically you can access any model now using Hugging Face transformer pipeline. I just wanted you to remember that. Sir, we can go to the slide. We have to be quick. Don't maximize it. I'll just tell it from here. So basically next is, let's say your model is ready. You build your model. Training we'll see in the next slides. But let's say your model is ready. You build a sentiment classifier where giving any sentence. Basically, let's say your student has given you feedback on your feedback platform, let's say, and you want to identify how many PDFs are positive or negative feedback, but you wanted to visualize as well. Now, basic way you can do is you can paste each, let's say, feedback and see whether it's positive or negative. So how you can do is you can build a simple UI. So this Gradio, Streamlit are very fast UI tools without not knowing anything about user interface building or applications, let's say front end coding. You can just, with 3, 4 or 5 lines of code, you can just build a UI that can showcase your build models, right? So sir, we can go to the that collab, same collab. In the same collab, yeah, you can go down. Yeah, basically I've given a demo of Gradio. So you just have to install Gradio. Because I'm using transformer, again I've installed it. I'm importing pipeline and Gradio here, pipeline and GR. Sir, go down. So we'll build a sentiment classifier. So basically, I'll build a function where, given a text, it will return back the label. So, and with this one line of code, you can have an interface like gr, which is gradio.interface function in predict. We have written a function. Basically, it calls this function. Input is text. Whatever text will give in that box, it will the input, and output is the level. Sir, can you click that URL? Once you run it, you will get a URL and a visual. Here also, in place, you will get a miniature kind of thing. I think it's not running, but it will just give you because yesterday night I've run it. It will give you a box on the left where you can put the feedback, and if you enter it, the positive or negative will be on the right. So just everything is there. You just have to go up and run all. Everything will be running, and I just want you to do it so that you get a flavor of what is happening. Sir, we can go to the slide. I think we have 5 minutes left. Yeah, this is done. Next is, so we have discussed about how in one line you can build the model, how in one line you can basically build a UI. Now, see, those models are already, let's say, pre-trained models or something, but let's take the case of feedback mechanism, right? So you want, because these normal, let's say, sentiment classification will be, let's say, trained on some Amazon product review, or let's say tweet sentiment, but it's not like customized for your education, let's say feedback sentiment analysis kind of task. So you have to train that, right, or fine tune that model. So basically you take that model in the Hugging Face, let's say, then you take your data, let's say make 1,000 examples manually labeled, let's say. So basically now you can label with LLM ChatGPT as well, but you have to verify it. So basically you take 1000 feedbacks from students evenly. Let's say your classes are positive feedback, neutral and negative feedback. Let's say you have 350, 350, 350 kind of 3 sets of equal distribution of all this example. Then you have to train it. But training, as raw training takes, you need to have a lot of knowledge about, let's say, neural network, let's say. Then you have to have knowledge about PyTorch, because you can use either PyTorch or TensorFlow. Let's say mostly researchers use PyTorch, so you have to have knowledge about PyTorch. Then other things, right? Which is not easy if you have not done it. So then to make life easier, or let's say to reduce the, let's say, if I want to get into NLP, I'm new, I don't know all this coding, but I should not stop doing, my creativity should not stop, right? So to reduce all this friction, let's say, so they have built this zero code or no code tools. These are called auto MLs kind of thing, where using very few lines of code you can even train the model. So there are 3 key tools. One is auto train from Hugging Face. Again, I'm including Hugging Face everywhere because using Hugging Face only you can be an expert in NLP. And again, one is AutoGluon from Amazon. I'll show example from AutoGluon. Then you have Google Cloud Auto ML as well. So this AutoGluon has all kind of tasks from time series, tabular data, NLP, vision. With basically 10 lines of code, you can literally train your model on this kind of task. So sir, we can go down. Yeah, I think some lag is there. In the next slide there, it will open another notebook. Yeah. Please open that. Yeah. In this notebook, I'll share, I've run 2 tasks, but if you want to, in that slide, I've listed other links as well, where they describe other tasks as well. Here, I'll just have a 2 minutes. I think we're running out of time, but just 2 minute walkthrough of how sentiment analysis and sentence similarity works. So you install AutoGluon. Sir, go down. Yeah, down. So basically, it's a kind of a same movie classification, I think, or same sentiment analysis, basically 1 or 0, right? Positive or negative. So go down. So this is how your test data looks like. So this is exactly in 3-4 lines you can just train the model. So basically from autogluon.multimodal, you can download the import this multimodal predictor. It will basically fit means train the model. So this is the model path where you want to save it. This is the predictor function, where basically in AutoGluon you have 2 columns. One is your input, the text. Another level is the level or output classes, let's say. You have this level, then matrices. What matrix you want to use, accuracy or F1. Then model path. Then you just do predictor.fit and pass the training data, and you can set the time limit. I've set 1000 seconds. So go down. I'll just show them how the accuracy increases. Yeah. So here you can see it ran for 1000 seconds, and accuracy from epoch 0, it was 0.55, 55%, let's say. It increased to 72%, right? So it is increasing. You can run it for more time or epochs to and use like there are various stopping criterion. So basically this is in 3-4 lines of code you can literally train a model. So go down. I just want to say what other things. Now you can, the following codes have the evaluation. So quickly go down. You can see individual sentence prediction. Go down. Using the trained, go down. Using the trained model, basically you can visualize the embedding as well. Go down, sir. We don't have time, otherwise I could have. Yeah, here you can see using the trained model, you can plot it like TSNE plot or something. Where you can see, because we have trained for 1000 seconds, bit segregating, not yet fully clustered, right? 2 classes, but since we can see there is a pattern, right? So if we run it for more cluster, it will become more evident. So at the end, we have one more task, but sir, we can go back to the slide because we don't have time. It's already 11. I just want to wrap it up. And after this, right now, this prompting came in
Hello.
ChatGPT, basically. Yes.
Sir, you can take 15 minutes more if you want. No issue, sir. Time is not a constraint.
Okay. Okay. Then let's go to the previous slide. I just want them to, yeah. So go down. Yeah. So next is there is another task called sentence similarity. So given two sentence, you can see here, a plane is taking off, an airplane is taking off. So basically this means the same thing, right? So the score is highest, like 5. Let's go to this 0.50, sixth row. A man is smoking, a man is skating. These are completely two different things. So the score is the lowest, not lowest, but very low, 0.50. So you can see here, mean score is 0, max score is 50. The task is basically given two sentence. You have to predict what is the similarity score. So go down. Yeah, so here you can see that was our training data using just 4 line of code. Same thing again. Basically same line of code, you can train this similarity prediction model, and at the end we can go to the answer. At the end I've done the same thing. Once you train the see here, yeah, here you can see the model. Go. This is loading the epoch is there. Yeah. First was yeah. Here it's the this one RMSE error, right? So it is decreasing. Accuracy should increase and error should decrease, right? From 65%, let's say, not percent, 0.652, it has decreased to 0.72. So like this means our model is learning, right? Sir, we can go to the slide. Yeah, I just want you to click this. There are 4 links. Just click the first one. So basically in these 4 links, I've given link to 4 text kind of task. We have talked about entity recognition. Basically in a sentence, you have to identify in this person or location, right? So using AutoGlean, I've given you this link because anybody wants to start exploring or NLP or something. This is a very good library. NLP, computer vision, or anyone. In the left, you can see this is under this multimodal. You can see object detection, image prediction, image segmentation. These are computer vision tasks. Text prediction, you can see these are NLP tasks. So a bit scroll down the left panel. I just wanted to show them. You can click in the document prediction. Basically from PDF, how can you can extract things, right? Scan document classification or PDF documents, then time series, how you can deploy those models. So this is a pretty good library to start exploring or start coding about these NLP models. Obviously, this is a start because you have very little customization available to you. Basically, you can train everything, but once you are comfortable with this, you have hands-on on training script, simple training script, all these things. Then you can move to Hugging Face so that you can play with different model parameters and all those things. Yeah, so I think you guys can go through it, so it will be good. Sir, we can go to the slides. Yeah, we can maximize it. After this, I will summarize my points. Yeah. So now, those all these things that I showed you uses some kind of small models. Small means 1 GB, 2 GB. Let's say I'm talking about GB, so that I don't want to go into parameters for now. But this Chat GPT, but those kind of models you can see. You have for each task, let's say classification task, you have to run a classification pipeline. For summarizer task, you have to run a summarizer pipeline. So there are different models tailored for each task, right? Then came a different kind of model. These are called LLMs, let's say large language models. Those were language models. Then it became bigger with respect to data and parameters. Right? Parameters are nothing but the weights the model stores. So it keep getting bigger and bigger. So now you can see your Chat GPT, it can do anything. It can just do summarization, it can do classification, it can do translation, it can whatever maths, whatever you want to do, they can do. So again, these are trained like the same thing. You have all this internet data, petabyte of data, scrape it, pre-train the model, which is called GPT. Okay, based on some training, let's say next word prediction or something. Once you have the GPT, you can, there are various kind of training like instruction fine tuning. Let's say you tell it to like give example, means again example works like input output. So basically you give a prompt instruction, summarize this paragraph, and you give a summary. This is manual levels. This is called instruction fine tuning. Translate, give an English sentence, output is your Hindi sentence. Translate English to Hindi. This is called instruction. You have to manually do it. Nowadays bigger LLMs are doing it, but yeah, somehow you have to have this manual supervision. So this is called supervised, let's say fine tuning or instruction fine tuning. Then it knows the instruction, but it's not yet chat GPT because it doesn't know how to chat with you. Then you train it on chat kind of data. So there's called, so then it becomes chat GPT. Let's not go there. So basically I wanted to talk to you about this prompting. So what are prompts? So basically giving natural language instruction, you can ask your, you can change your LM's behavior. Like you can change changes to act as like a classifier or like a translator, a summarizer. Like there are various kind of prompts. Some basics included, like instruction prompt, like summarize the following paragraph in one sentence. We all use it. Zero shot. If you start, let's say, doing in industry, let's say nowadays everyone is using this LLM classifier, LLM summarizer, or LLM sentiment classifier. Basically, you don't have to do anything. You write to simple prompt like this. First step is always zero shot classification. Classify this message or tweet as spam or non-spam. Then you give the text. This is a very basic kind of prompt. I'm not given the code how you, in the next slide I think it is there. So basically given a text, it will identify spam or not spam. This is how the basic code looks like. Then it will give you good results, but somewhere it will tank. So basically somewhere it will fail because LLM, we know it hallucinates or something happens, right? So now what you do is you give it some positive and negative examples so that it knows, Acha, if this kind of thing happens, I should categorize that spam. If these kind of things happen, I should categorize that non-spam. You can give edge cases so that it handles better. This is called few shot prompting. Few shot means few examples you can think like that. So basically here you can see, so I want to build a question answer system. So in my prompt, I say that whenever I give question, what is bird? Answer should be a transformer encoder model, short answer, right? So next, I'll give the next question, what is GPT? And I'll ask it to, see, I've told you everything is next word prediction only. So I've asked it to complete it. So basically what I'm asking is whenever you give this kind of question, now normally if you just paste what is GPT, it can write a paragraph as well, right? So, but I don't want it. I want my answer to a short sentence. So you are changing it behavior like a short answer giver kind of thing. Then if you want to do this prompt tuning or prompt engineering, so there are particular way of writing the prompt. Basically you assign a role to the LLM. You are an expert in sentiment, you are an expert sentiment classifier. You have sentiment tweet classifier or something. You are an expert in biology, bio disease classifier. Like this, you are a helpful teaching assistant, this kind of. Then you tell it what to do, classification and other things. Then sometimes bit advanced is like chain of thought prompting. If you basically you think of LLM as a child and tell it how a child would solve. Let's say I was having 4 apple, then I ate 2, how many remaining kind of. If your like LLM is not able to answer few bit complex question, reasoning kind of, then you can do this chain of thought. Chain, you can build a chain, right? How a child thinks. We can go to next slide. So yeah, I've given few screenshot because I could not. Nowadays, I think the ChatGPT is not giving free credits. You have to buy it. So I have included few screenshots from ChatGPT itself. Right. So this is how zero shot prompt looks like. Classify. The movie was a total disappointment. Options positive, negative. This is a zero shot classification. The output is negative. Few shot, you do the same thing. Classify the sentiment. Then you give some examples. When I say I love this product, it should be positive. It broke on day one, it should be negative. This is like a Amazon product review or Flipkart or Myntra product review. So next, the packaging was excellent. So it will identify the class. Next is chain of thought. Let's say, so basically question, a person buys 3 apples and eats one, then they buy 2 more. How many apples do they? This is very basic thing, step by step. You can do. Just search for this, so you'll get to know what are these, right? Next. Yeah, few before we wrap this tool section, I wanted to highlight few other tools. So let's say Llama Index. So it connects these LLMs to external data sources, right? Like PDF, Excel, or database. So what is the issue with the limitation of LLM is that it is trained on some backdate. Let's say your ChatGPT is trained on last month, because training them cost millions of dollars, right? So if you ask, let's say now, say after training, some election happened, like US election, let's say. Now, if you ask who is the election of president of US, it might not know if it is only relying on the LLM knowledge. So now you want it to connect to like some resources, like if there is a PDF which tracks up all these things, or database or docs or internet as well, right? Right now, if you ask ChatGPT, you can see it is searching in internet. It's basically become a agentic system. So it can search everywhere and give you information. So Llama Index is one such framework. Then LangChain is one such framework where you can build a structured agentic workflow using LangGraph and all. I'm just giving this term so that whenever you explore, you know this. Then obviously we can use LangChain to build chatbots and then RAG and all those things. Then Fast API I just wanted to include because once you build your model, you have to this come in model deployment. Let's say you have to like host it somewhere in a cloud or your local server or somewhere. So this Fast API comes into play. I wanted to cover MLOps, but due to time constraint, I didn't. We can go to next. Yeah, so to wrap things up, whatever we covered today, let's revise. So we started with the idea that we no longer need to train everything from scratch. With pre-trained models and tools like Transformer, Hugging Face, you can build classifier, summarizer in one line of code, let's say. We saw how notebooks like Colab or Kaggle give you free GPU access and space as well, and how UIs like Gradio and Streamlit. I've shown you Gradio. Streamlit is one such app. Can use this model to showcase or make it usable, let's say. And we also see no-code tools like AutoML or AutoGluon, which lets you train models with 3-4 lines of code. And the real message here is you don't need to be a very good coder or good model architect, let's say, to build what you build. Okay, so with this no code and all these platforms, you can accelerate your journey to building. Am I audible, sir?
Yes, sir, you're audible.
Okay, so yeah, we'll go to last slide. Yeah, so I want to leave you with this one idea. So the faster you prototype, the faster you learn what actually matters in real life or practical scenario, right? And in NLP and AI more broadly, it is easy to get caught in complexity of the models, parameters, all those things, perplexity, all those things, and benchmarks. What is the accuracy? What is the fun? But in in practice, or in, let's say, what we are doing in industry or somewhere, whoever, the real progress often comes from rapid experimentation, trying out ideas or getting feedback and refining it. So I just wanted to tell you, build fast. Don't wait for the perfect data set or architecture. Use what is available, validate your intention, and improve from there. You don't have to learn too much to start coding. Just do all these. At least you start. At least you run these. I want from you as all these notebooks that I've given. At least you go and run and see cell by cell what is happening. And I hope in this session I have given you some overview of some practical tools and inspiration to start building NLP tools, whether it's for a project, paper, or just for curiosity. So I have something I've contributed, right? So thank you. And I'd love to hear what you prototype next. So we'll open to the questions or ideas. Or first of all, was it interesting, and what more you could have wanted out of the session?
Yes, participants. Do you have any doubt? If you have any doubt, then write please on the chat box.
Yeah. Any feedback, anything is fine. So one question in the chat is, explain Hugging Face again. Basically, it's a repo, you can say, basically, which hosts all these models, data sets. And it started with that, then started building pipeline where people can, with 1 line or 2 line of code, directly access those models that people have shared and build more. For multimodal example, what was the input and what was being predicted? So if you go to AutoGluon, you can see that in multimodal thing, see, modality means, let's say, if image is one modality, audio is one modality, text is one modality, right? So multimodal means, given a image, let's say image captioning, given an image, you describe what is happening in the image, right? So basically, I give you an image of a, let's say, dogs playing. So your model should be able to identify scene understanding. It should identify what is happening in that scene or image, and it should give you a proper statement like 2 dogs are playing or something. So this is one such. If you truly mean multimodal, or in the AutoGluon, if you mean multimodal, means they just do it like image segmentation, classification, like that. But multimodal examples are image captioning, audio captioning. You listen to a audio and your model should be able to output what is happening in the audio. Let's say VQA, visual question answering. So basically, you have seen many times in, let's say, you're logging to some website, then this captcha will come like, what is happening in this, like which are the traffic posts in this image, right? So those are the training data for them. So basically, next time one image comes, you can ask question to it, are there any traffic posts? So if it is seen in the training data, it will be able to say yes, in this let's say bounding box, traffic post is there. This is how this multimodal works. That's a nice question. If you have any question, please go ahead. Anything, you can ask anything. It doesn't have to be technical, right? Or any feedback what you have wanted to include in this session, or what you were expected and it was not there. Anyhow, all these things will be shared with you. So at least what I want is you click those notebooks, Ocolab notebooks that I have built. Just go select GPU and run all. and see what is happening. But go through cell by cell. If you have any doubt, just paste the cell output or cell content to ChatGPT and ask it to explain it. So nowadays learning become very easy. You don't have to rely. I think if we don't have any questions, sir, we can conclude, I think.
Yes, sir. So it's really a very good suggestion, sir. So that you already shared all the files. So participants, I request you please just run all this collab file and just ask if you have any doubt. Just chat or you can just mail to sir, or you can write in chat box today that we are here up to 7 o'clock. So although it's a last, but you can write the mail or whatever. So thank you, sir. Thank you very much for giving this insight. So you shared all the file
Yes.
and explained very
Thank
nicely. Thank you, sir. Thank you.
Yes. And you can, sir, please share the slides with them as well. It will help them. Yeah.
Yes, sir. Thank you.
Okay.
Sure,
Okay.
I will do
Thank
that.
you, guys. Thank you. Yeah. Bye-bye.
Yes, sir. Thank you. So hello participants. So now it's a time of 11:20. So just you take a 5 to 6 minutes